just leaping straight into it. What's a loop for? A loop is so that you can repeat code. I think we may have used the terms flow of control, maybe not in this class. That sound familiar? Flow of control for this class? Okay, so what we have, still need to give everybody credit for that one. So that's at least a point, I think. Okay, so anyways, flow of control is the order in which statements are executed. And most books list 3, but there are really 4. But they're sequential. I'm going to declare a variable. I'm going to add 10 to it. I'm going to print it out. Sequence. Then there's branching. Branching are the if statements. If that number is equal to 10, print something. Else, print something else. So branching is conditional code. Something is sometimes going to execute and sometimes not. Then you have looping. Looping is when it repeats code so that you can execute the same set of instructions over and over and over. You can be sure that a video game is looping a whole heck of a lot in order to update its screen, every time that you move your characters or whatever. So, and then there's a 4th kind, which are function calls. Function call causes it to leave main entirely, run off somewhere else and start doing some code. Then it'll do that code and eventually it'll hop back. It's like telling somebody else, go do my work, and you just sit there and wait, and then they come back. So those are the 4 types of flow control, and we've been using this all along. We've been using branching all along. And I know I've thrown in a while true or something like that, I think, but we're going to learn more about loops now. So that's where we are. So in order to use loops, we tend to use an increment or decrement operator, which adds 1 to a value or subtracts 1 to the value. I'm sure we've seen this already. So if you do val plus plus, it's the same as saying val equals val plus 1. And the plus plus can go before the variable or it can go after the variable. And to some extent it does the same thing, but in some extents it does not. One's called prefix. That's the prefix increment operator. That's the postfix increment operator. I need to close one of my 2 notepad files. Seem to have 2 of them going on already. So if you do this, a is equal to 10, and then you do a plus plus, we've seen what happens. What's a after that? It's 11. So if you do this, a is equal to 10, b is equal to a plus plus. What do you think b would be? You think b is going to be 11, right? Because it's going to do this, and then it's going to copy that result. It doesn't behave that way, though. When we're done with this, b will be 10 still, and a will be 11. Now I'm going to rewrite it. A is equal to 10, b is equal to plus plus a. Now when this executes, b will equal 11, kind of like we suspected it would be in the first place. Also a is 11. So why the change in behavior? Because depending on whether that falls after the variable or before, determines when the increment happens. If it comes before the variable, it's the first thing that happens. Before even the line is processed. It just happens right away. So 10 becomes 11, and then everything else happens. But if the plus plus follows the variable, it's the last thing that happens. So it's kind of like it was written like this. This one is sort of like it was written like this. B is equal to a plus plus. That's the equivalent. And this one is written like this. A plus plus, B is equal to A. See what I'm saying? If the plus plus, no. Like that. If the plus plus happens before the variable, it's the first thing that happens before anything else in that statement. If the plus plus follows a variable, it's the last thing that happens. So 10 is copied into B, and then A is increased by 1. Here, 10 turns into 11 before the B gets copied. Now, if it's all on its own lonesome, if it's all on its lonesome on a line all by itself, it doesn't matter. You know, if you do A plus plus just on a line all by itself, or you do plus plus A, doesn't matter. A still gets incremented. It's when you mix them inside equations like that that it starts to matter. And supposedly plus plus A is a little bit faster than A plus plus. So if you were trying to write the absolutely maximal speed program, you would use that if you could. We're not really trying to do that, but just tuck that away in your head. Okay, so plus plus is called increment. It increases by 1. Minus minus means decrement. It decreases by 1. Also can be used with a prefix or a postfix before or after the variable. Same rules. If it's a prefix, if it comes before the variable, it's the first thing that happens before the line is processed. If it follows the variable like this, it's the last thing that happens. So these can be used in complex statements and expressions. In prefix mode, the operator increments and then returns the value of the variable. In other words, it's the first thing that happens. In postfix mode, it returns the value of the variable and then increments or decrements it. So it's the last thing that happens. All right, this just reiterates the point I spent 5 minutes talking about already. So we have something called num and we have something called val. So then we try to write out val plus plus. And if we didn't have the answers here, thank you very much. Is this going to print 12 or 13? You probably already saw the answer, but what's it going to print? Well,
12.
It's going to print 12 because the plus plus follows the variable, so it's the very last thing that happens. So it prints out 12, and then value becomes 13. How about this one? What is it going to print out? It's going to print out 13 because it's the first thing that happens. Same rules down here. It equaled, well, I wasn't keeping track of it all the way through, you know. So if it equaled 12 at this point, it's going to print out 11, right? And then if it equals 12 at that point, it's still going to print out 12, but it's going to be 11 afterwards. Now what they probably expected us to do is just track the value of the variable all the way through. So after this line was done, it would have equaled 13. So this would have printed 14. I'm not quite sure what they meant. When I pull the answers back over, we'll find out. And then this would have lowered it back to 12, and it would have printed out 12 a second time there. Let's go see. Think so. Anyways, we did it right. You can use them in expressions. Result is equal to num plus 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 minus minus num. All right, now your brain starts to break when it does that. I don't really think that I would do that, but you can. This is more common. If plus plus num is greater than limit, so that as you compare it, you increase it. Or more commonly, while num plus plus is less than 10, that way it'll check it. Is my number less than 10? And then it goes ahead and increases num. That kind of thing. Although I can see why you might prefix it like that. Introduction to loops, the while loop. We know what a while loop is. A loop is a control structure that causes a statement to repeat the general format. While, expression, statement. Statement can either just be one line of code or it can be a block of statements as long as the block of statements is enclosed in braces. This is your expression. As long as this expression is true, it will go ahead and enter the loop, and as long as it stays true, it'll stay inside the loop. Then if the expression ever becomes false, it'll bail out of the loop. Our classic one, you know, x is equal to 0. While x is less than 10. Print x. x plus plus or plus plus x. Either one would work. All right, so what's it going to print? It's going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's not going to hit 10 because once x becomes 10, it's no longer less than 10, right? 9 is less than 10, so it'd go ahead and repeat the loop one more time, but then when we added 1 to x and it became 10, 10 is no longer less than 10. Another way you could write the same exact behavior would be to do while x is less than or equal to 9. Then, if you started off at 0 again, and you did that, then again it would iterate 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You just have to check to see if it's less than or equal to. Which way do you like? You like writing it like that, or do you like writing it like that? It's your choice. This is kind of cool because it makes your choice. Which makes more sense to you? How many numbers are being printed, though? 10 numbers are being printed, right? Even though it only goes up to 9 because 0 counts as a number 2. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that kind of matches that. On the other hand, our highest number is 9, so that matches that. But they do the same thing. So while expression statement, the expression is evaluated. If it's true, then statement is performed, and then expression is evaluated again. If expression is false, it doesn't even go into the while loop to begin with. If expression was true, but somehow statement changes it, then once it comes back up here and checks it again, then it will leave the loop. That makes it sound more complex than what you already understand, I'm sure. Their version of a while loop logic. Is the expression true? Yeah, it is. Run some code. Then come back and check the expression again. Is it still true? Yeah. Run your code again, your block of code. Is it still true? Nope. Drop out. If this expression wasn't true to begin with, for example, my code here, if I set x equal to 20, and then I said do this while x is less than or equal to 9, well, is x less than or equal to 9? No, it's 20. So it wouldn't print out anything. Can't even get into it, just like an if statement. Now, one thing you'll see people do, experienced C programmers and the like, is they'll combine this into one step. Hey, I'm just going to be incrementing x anyways. Why don't I put my x there? You can do that. I don't encourage it. I like seeing my increment down at the bottom rather than hide it in the middle of code.
So that plus plus wouldn't show up in the CO?
Not if it's there because it's the last thing that happens. Remember, if plus plus follows a variable, it would print out, well, if we change this back to 0. It'd go in here, it would print out 0, but then as soon as it hit the semicolon, it would change it to a 1. Flowchart. While the number is less than 5, print hello, add 1 to it. And it'll keep doing that until the number is no longer less than or equal to 5. While loop is known as a pretest loop. The test happens before the body of the code. It doesn't do this code and then come up and check it. It checks it and then does the code. So if this isn't true, which in this case is not, it doesn't do this code at all. The test happens first. This is the gatekeeper into that code. If this is false, which it is because 6 is not less than 5, it won't perform that code. So the loop must contain code to make expression become false. At some point, this has to become false or it's an infinite loop. Now we've used break statements, I think, right? Break sound familiar, thumbs up, thumbs down. That's the way around that. If the code doesn't contain a way to make expression false and it doesn't have a break statement, that loop will continue until the user terminates the program. That's called an infinite loop. The loop has no way of ever stopping. Here's one. Number is equal to 1. While number is less than or equal to 5, print hello. It's going to print hello for a long time. Why is that? Because we never change the value of number. So number is always less than or equal to 5. To fix that, what would we have to do?
Break.
No, let's not use a break. We want to change the value of numbers so that eventually it's no longer less than or equal to 5. Yeah, we just need to increase it. Like that. Now it's a good loop. Now it's not an infinite loop. Now it really would print hello 5 times, which is what it was designed to do to begin with. A lot of times when I'm typing in a while loop, I forget to do the increment. And it winds up being an infinite loop, and I have to go and edit the program and then demonstrate it again. Using the while loop for input validation. You can make sure that people type in a good value by using a while loop. You're asking them for their weight. You don't want to let them enter a weight of 0. Input validation is a process of inspecting the data, determining whether it is valid. And the while loop can be used to create input routines that reject invalid data and keep repeating until valid data is entered. So here's how they do it without using a break statement. You read an item of input. While the input is invalid, you display an error message and you read the input again. And then end your while. Now there is actually no end while statement. This is just pseudocode. Let's go ahead and do that. We haven't typed in anything yet. So an empty project. Why am I only on project 3? We've done a lot more projects than 3. Something's odd with my machine, but I'm not going to stress about it. And my Solution Explorer's gone. There we go. So I did view Solution Explorer. I'm going to go to Source Files and do Add New Item. Choose a C++ file. I think I'll change the name of the C++ file to October17.cpp. And then good old boilerplate. And I'm not going to even read the boilerplate. Y'all are used to typing this. I keep saying that at some point we're going to stop doing that using namespace std. I guess we didn't hit that point yet. At the bottom of it, put your system pause, except for our Mac users, don't bother, and then return a 0 out of it. Okay, so we wrote programs earlier that needed your height and your weight. Let's do that. Cout, well, let's declare our variables first. Double, inches, and then double, pounds. We're not going to write the whole program. We're just going to do some input validation. Let's tell them what we want. Enter your height in inches. \n. Now let's read it in. Now let's check it. Those dirty rascals may have typed in a height of 0, or something that's impossible, like 10 feet tall. So we're going to check if inches is less than 0, meaning it's a negative number. Could make it less than or equal to 0. Less than or equal to 0, or, so 2 vertical bars, shift \, inches is greater than 120, which is 10 feet. Let's yell at them. Cout inches must be between 0 or 1 and 120. Then we better ask them again. Cout, enter your height in inches, \n. And then read it back in. CIN into inches again. So why do we do that? To make sure they're not entering garbage data. You could ask them for their zip code, and if they enter something that's fewer than 5 characters long, you know right away it's not a zip code for this country. You could even conceivably have a list of valid zip codes and check to see if it's in there, you know. I like using my 9-digit zip code because I know my 9-digit zip code, and then I type it into a web form and it says invalid zip code because they only want 5 digits. So, okay. Same thing here. Let's ask for their weight. Cout, enter your weight in pounds, /n. And then CIN into our pounds variable. And then guess what? We need to check it again. If they type in a negative value or something greater, then I don't know what our maximum value is. Let's say that there's nobody in here that weighs more than 1,000 pounds. So if pounds is less than or equal to 0, I misspelled your, or pounds is greater than 1,000, then we're going to give them an error message and ask again. Cout, pounds must be between 1 and 1,000, \n. Then tell them again, Cout, arrow, enter your weight in pounds, \n. And then CIN back into the pounds variable. Alrighty. For this particular method to work, it requires what's known as a priming read. A priming read is when you do a read before you do the loop. Right? We had to have a valid value, or we had to ask them for their weight before we could see if it was valid or not. So this is known as the priming read. And then if they enter bad data, you know, we have a looping read or something like that. There's got to be a good term for it. I don't particularly like structuring my code like this. I don't like having 2 places where we display the message, enter your weight in pounds and CIN. I'd rather we only do that once. The way you can accomplish that is with a break statement. But I'm just going to roll with it. This is how the book is telling us how to do it right now. So if you're going to do input validation in this fashion without a break statement, you need a priming read. You need to display a message. You do your priming read. You check to make sure you have good data. If you don't, you tell them that it's bad data and you give them a second shot at it. Then a third and a fourth and a fifth and so on. So I'm going to go ahead and build it and run it. Rebuild solution. Run it, enter your height in inches. I'm -10 inches tall. It says no, must be between 1 and 120. Enter your height in inches. I'm 13 feet tall. It accepted that one. I've got a problem there. Enter your weight in pounds, -1. Oh, I should have used an and rather than an or. We have talked about and or, have we not?
Yeah.
What is wrong with my logic here? If your inches is less than 0, No, I don't see anything wrong with the way that's worded. Why did it accept 130? I don't know, but I'm going to rewrite this because it didn't work for me. If inches, no, I don't see why that didn't work. I'm sorry, guys, I'm kind of perplexed by this. Enter your height in inches, 1,000, 10,000. All right, that worked. Enter your height in inches, 10,000. The second time it let me out. Is anybody seeing why? Because I'm not. How about weight? Is weight working correctly? Enter your height in inches, 60. Enter your weight in pounds, 10,000. Well, for Pete's sake, what am I doing wrong? This is the easiest logic on the planet. What am I doing wrong? I guess I'm going to print out inches and pounds after the loops just to see what they actually are. So C out inches equals, end quote, arrow, arrow, inches, arrow, arrow, ENDL. And the same for pounds. C out pounds equals, end quote, arrow, arrow, pounds, arrow, arrow, ENDL.
Properly.
I am totally not seeing it. Which one did you say was working?
Inches will work.
It's not working for me.
I think I know why it's not working. Because don't you need like a break statement? Because if it's 130, then it goes inside the brackets, and it says inches must be between 1 and 120. But then it just goes down to the next
Oh,
line.
for Pete's sake, I see what I did wrong. And yes, doing a break statement would be a perfectly good way to implement data validation. But what chapter are we on? We're talking about loops.
A while loop works.
We need while loops, not if statements. Alrighty. Well, that wasted 5 minutes of our lives. Okay, so while inches is less than 0, or inches is greater than 120, and now it will work. Alright, seems to be working for me. That's input validation with a while loop, and you absolutely can implement them with a break. You're absolutely correct. I'm going to kind of skip that for now. I'm sure that we have done that in prior loops where we did while true, and then we got some data and we checked it. So yeah, you can do it that way, and that's actually my preferred way. All right, anybody need any syntax error correction? All right, so you read an item of input, that's your priming read. While the input is invalid, we were checking to see if it was outside of the range. Display the error message and then read the input again. And they give an example. Enter a number less than 10. Type it in. While the number is greater than or equal to 10, yell at the user, invalid entry, enter a number less than 10. To belabor the obvious, flowchart for input validation. Read the first value, our priming read. Is the value invalid? It sure is. Display an error message, read another value, and then come back here and do this again. And no, we're not going to look at code that demonstrates it. We've seen that enough. Counters. Counter loops. A counter is a variable that's incremented or decremented each time a loop repeats. So you want to count all the numbers between 1 and 10. Use a counter. It can be used to control the execution of a loop, in which case it's known as the loop control variable. Am I going to remember to call it the loop control variable very often? No, I'm probably just going to call it a counter. You have to initialize your counter before you enter the loop. Let's give an example of that. Let's not do that. Let's go in here and write a loop that depends on a counter. While, x is less than 10, cout the value of x, followed by endl, and then let's increment x. Alrighty, we see the problem already, right? It's underlining x, and why is that? Yeah, we never initialized x. So create a variable called x and set it to 1 or 0, whichever you like. I'm going to go 0 up to 10, so it's going to count 0 through 9. And then when I run it, it prints out 0 through 9. So that's a counter. X is our counter. X is also our loop control variable. So here they're printing out all the numbers between 1 and 10, and then their squared values. So let's make a cute little chart like that. That prints out the number squared, and then the number cubed. We already have a while loop going on here. We could just reuse that. I'm going to take that out. Guess I'm going to leave part of it though. I'm going to print out x, and then I'm going to print out a tab, followed by x squared. POW x to the power of 2. Now, Olivia, I think you're going to have to do a # include C math to get that POW to work. And then I'm going to print out another tab. So cout \t, and then print out the power of x to the 3. And then I'm going to print out an endl. And could we have done all that in one long line? Absolutely. Well, let's see if it works. Yeah, there's our little table of squares and cubes. 9 squared is 81, 9 cubed is 729. So we're using /t as a primitive table formatting mechanism. But that's not too cool. We ought to be using setW. Why? Because eventually the tabs are going to stop working. I don't feel like demonstrating that right now, but you probably know the idea. If your data becomes too long to fit in a certain tab, and then you hit tab anyways, then it goes one past where you wanted it to go, right? It goes the next tab over, and your data no longer lines up. So setW, the I/O manipulator, would be the right way to do that. All right, guys, I want you all to write a few more loops for me. Write a loop that counts from 10 to 100. And then write a loop that counts from 20 to 40 by 5s. And when I say counts, I mean prints the numbers. Counts and displays. How are you going to do that thing where you go up by 5? You could do it the hard way, or you could do it the easy way. The hard way would be using modulus. And by the way, thinking of modulus, a lot of y'all said that if you have x is equal to 5 and y is equal to 2, that x mod y is equal to 3. But it's not. That's more like x minus y. And I kind of got why you said that, but What does modulus really mean? It means you take this number, you divide it into there, and you get the remainder. So 5 divided by 2 is what? 2, with a remainder of 1. Okay, so anyways, you could use modulus in order to fulfill, don't cancel that, the needs of this second loop. But instead, you're just going to use x plus equals 5. Or whatever counter variable you're going to use. And then lastly, do one that counts down, a ticking bomb, from 10 to 1. And for that one, you'd use minus minus rather than plus plus. Alrighty, somebody who's done all three. Anybody done all three? I'm sure somebody has. You're getting there. I know somebody's done the first one. Read me the syntax for doing the first one. What should my first line of code be?
Y equals 0. Are we doing 1?
Yeah, let's do 1. So we need a loop control variable. Let's just reuse x. What am I going to set x equal to? 10. Right. And then what am I going to make my while statement? While, and there's more than one answer, while x is what? Less than? Are we going to do less than 101 or are we going to do less than or equal to 100? Either works. I like less than or equal to 100. All right, what goes in my while loop statements? I'm going to see out x followed by ENDL, and I'm going to add 1 to x. All right, how about 20 to 40 by 5s? Very similar syntax, right? We have to initialize our variable, or at least assign it, our loop control. So x is equal to what? 20. And then while x is less than, what are we going to do here? Yeah, we could do less than or equal to 40, or we could make it less than 41. And that kind of doesn't make me happy, so I'm going to do x is less than or equal to 40. And you Python programmers would be using ranges for this. We could use for loops for this. We will learn very quickly how to use for loops to write the same code. And then see out x, ENDL, x plus equals 5. Go up by 5 each time, please, Mr. Computer.
Why is that?
Because you put stuff after system pause and return. Cut those 3 lines and move them to the bottom.
So how can you name the or?
That's that one.
No.
Shift. Backspace one more. Yeah, get rid of that slash. Now shift like that. Sorry guys, if we haven't talked about and, excuse me, or, it's shift backslash. So you have to get both of those and then you get the vertical bars.
do like columns? Would I have to do like set precision or something? Or set W?
If you wanted to be evenly spaced,
Yeah.
yeah, you'd go up and do pound sign include, IO manip, and then before each number you wanted to print, you do a set W.
Okay.
So not set precision is for floating point numbers.
That sounds cool.
All right, so I'm going to do my for loop that goes from 10 to 1. There you go. I'm better off now. Yeah. So you just initialize it to 10. X is equal to 10. While. All right, Olivia, how did you word this last while statement?
While x is greater than or equal to 1.
Yeah, I like that. The other thing you could do is x is greater than 0. All right, and then C out x ENDL, and then I want to subtract one from it, so x minus minus. And then just for funsies, since we were counting down, I'm going to print kaboom. All right. Guess that's not funny. I'm going to delete that. All right. All right. We are pretty close to being done for today. I'm going to hit the PowerPoint, see if there's anything else I want to cover in the last 2 minutes. The do-while loop. The do-while loop is just like the while loop, except a little bit different. Let me show you what do-while looks like. Let's set x equal to 10. I'm going to write some code again that counts from 10 down to 1. And then I'm going to type the word do. And so I'm going to print out x. Maybe I'll print out the word do in front of that. So D, C out, arrow, arrow, do, while. You know, just to show that something different is going on. And then I'm going to subtract 1 from it. But then I have to tack on a word down here at the bottom. While x is greater than or equal to 1. So what's the difference? Well, this one's going to run exactly the same way. It's going to count from 10 down to 1. But there is a difference in how it behaves. All right, so it printed 10 down to 1. And here's the difference. You see your x is equal to 10 above your first while loop? Change that to like -5. And then do the same thing above your do while loop. X is equal to -5 on both of them. Above your while loop, change that 10 to a -5, and above your do loop, print, change 10 to a -5, and watch how it behaves. Check it out. It didn't print down 10 to 1. It didn't print down anything, right? It skipped straight from our going 20, 25, 30, 35, 40 down to our do while. Now, why is that? Because if this is set to -5, is this condition true? Is x greater than 1? Greater than or equal to 1? No, so it doesn't print out a darn thing. What if we go here, though? X is equal to -5, do. All right, print out something. It has to do that. And then it subtracts 1 from x. So now x is equal to -6. And is -6 greater than 1? No, it's not. So it falls out of the loop. So a do loop is a post-test loop. And the Python language doesn't have a do loop. For y'all who are taking the Python courses. While a while loop is a pre-test loop. What's the difference? If it's a post-test loop, the test doesn't happen until it's already executed the code, right? It printed out the value of x before it ever checked. So you use a do loop if you want this code to happen at least one time. Our input validation routines could be rewritten using a do loop, and we wouldn't have to have a priming read. Because we could force it to do the input, inside the loop, and we would be guaranteed it would happen at least one time. So we wouldn't need to put it above it as a priming read. So let's put our little rule here. Use a do loop, also known as a do while, if the code in the loop needs to always happen at least once. Now the word happen is pretty childish. Be executed. You know what I mean. Because a while loop, the code doesn't have to execute at least once. Because if this condition is false, it won't do it at all. I'm going to change those x's back, those -5's back to 10s, just because I don't feel like uploading the code like that. Alrighty, that's a do loop. Do loops are post-test. The code in here is performed before it's checked. So you know that this is going to happen at least one time. Let's make a Dropbox for this stuff.